Now, last week I told you, and I looked at some Venn diagram theory and basically what it means. But if you ever see this word given, that means that we're talking about the probability. In other words, we're looking at the probability of A occurring given B. Now, we looked at the Venn diagram and some of us didn't make too much sense of it, but in your bound reference, you can have, of course, just the formula, if you like. What is the probability of A given B? Well, the formula is the probability of A intersection B over the probability of what?
B.
Probability of B. Okay. Now, we're told that the probability of A intersection B, well, we found that calculate the value of A intersection B, and I'm just going to say that we've already done that using the addition rule last week, so I'm just going to tell you that the probability of A intersection B using the addition rule was 11 over 24. Okay, now, so that was from the previous question. So what we have 11 over 24, and the probability of B was 2/3. Okay, now let's have a look at that. It looks a bit ugly, doesn't it? But let's do it this way if you like. This might be a little bit easier. 11 over 24 divided by 2/3. Wow. Let's change that divide to a multiply. Shh. There's too much noise in here. Shh. Sebastian, I noticed that you, in particular, are a bit off with the fairies today. Yeah, nothing to do with his shaved head. I'm just talking. Come on, keep up with the program, will you? All right. Now I wouldn't go ahead. I could multiply and I could say 33/48, which is fine. But I could do some simplifying here. 3 goes into 24 8 times, doesn't it? And then I'm left with 11 over 16. Would you agree? All right. Conditional probability, not so bad, especially if you just use the formula. Sometimes, however, you might be given a Venn diagram, and it's actually quite easy. It's actually quite easy to read directly from a Venn diagram. You don't necessarily need to use that formula. But if you prefer that method, go for it.
How do we use it using the Venn diagram?
Using the Venn diagram, what we're basically saying is it's basically like saying we'll have a value in here, and we're actually using just this sample space here because that's B. Okay? And the probability of A given B, well, let's just say that there's 11 in here, and then there's 5 in here. Yeah? So the probability would be 11 out of 16.
Yeah.
Does that make sense?
Yeah.
So if you had a Venn diagram, you wouldn't have to use that formula. Okay? All right. For the time being, shh. Tennyson, you had a question? All right. So the answer in last year's solutions were wrong. I just grabbed them from there. So thank you for raising that. That is what we had 9 out of 24 plus 16 out of 24 minus 22 over 24, which you're right is 3 out of 24 or 1/8. So that means this is changed, isn't it? Sorry, I just grabbed that from last year's solutions. I didn't work my way through it. So let's do that. That's going to make our life easier. 1/8. And let's do that again, shall we? So we've got 1/8 times 3 over 2. So the answer is 3 over 16, yes? Okay, thanks for raising that. Okay, dokale. Now, yeah, correct. All right, so conditional probability. Whenever you see that word given, use the formula. However, for there may be the 7 or 8 students in here, you might make that association that if we were given a Venn diagram, it is actually a fairly straightforward thing. Because we're only looking at a sample space which is B. How many of those are A, basically? All right. Now, let's have a look then at tables using multiple events. Now, we've used the two-way tables, but in this case, let's fill this out. In this example, we've got a square and a circle. Both can be shaded separately. Now, as you can see, we've got two sort of separate events here. So I've already set this table up, so we can say that we could either got indigo or tan for the square. And in the circle, we've got indigo, lilac, maroon, or tan. Now, what you might want to do with this one is let's now fill out the table. These are all the events that are going to happen if I can do... They're just different colours, man. You know, get over it. All right. So, let's have a look. Let's fill out this table. I have this. Now note, I know it's like last period on a Friday, but we unfortunately, let's do the square first. Okay, so whatever the thing is first is the square. So we've got, that's TL, that's TM, and that's TT. Now notice that this is this is with replacement. In other words, we can pick the same colour twice if we like. So there's going to be two separate tables. There's going to be one with and one without replacement. The question is, what is the probability that at least one shape will be shaded indigo? Okay, so how many outcomes do we have? 8 outcomes. So by using a table, and you don't have to do this, but in your test you might be asked to use a two-way table. If you're asked to do a two-way table, please do so. So how many will at least one shape means that it could be both be indigo or one indigo. So we're happy with 1, 2, 3, 4, 5. So what's my probability of indigo, of at least one indigo?
5 out of 8.
That's correct. One.
The replacement, is it just that you're putting a...
This time, however, replacement's not allowed. So let's do the same thing. We've got indigo and we've got tan. And we've got indigo and we've got tan again. And we've also got lilac and maroon. Doesn't really matter which order we put them in. But without replacement, there's no possible way we can pick indigo twice. We can only use it once. So what we'll do is put a little cross in there. Not going to happen. Indigo tan. We've got indigo lilac, indigo maroon, tan indigo, tan. Thank you. There's a big cross there. And then we have that and that. Now, how many possible outcomes do we have? 6, because if I was to, and I'm going to link this to a tree diagram, if you think about it, without replacement, if I was to pick a square, I can go indigo and then I can go a tan. If I go an indigo, I can't go another indigo. I'd have to choose a tan, a lilac, and so we're going to actually get to tree diagrams. But if you think about it, there's 3 outcomes there if I choose indigo first. If I choose tan, then I've got indigo and I've got L and I've got M. Notice we can't replace. So I've got a total of 1, 2, 3, 4, 5. Well done. We can count to 6, people. That's great. So we've got a 6 outcomes, don't we? And so if I've got 2 repeated trials, it might be a benefit to do a 2-way table like that, especially when we've got with and without replacement. Is that making sense? That stuff's pretty straightforward, isn't it? Yeah, Lorenzo, you had a question? I might just pause it. I'm just going to resume here. So the probability that we had of it being shaded indigo is 1, 2, 3, 4, 5. No. Probability of indigo was equal to 4 out of 6. But you know what? I would like you to simplify that to 2/3. Thank you. All right. Are there any questions so far about that? All right. Now let's look at some tree diagrams. Shh. Now, can someone tell me what would be the odds of correctly guessing 2 multiple choice questions which have 4 options? What would be the odds? 1 out of 16. Okay, good. But you might be asked other things like what is the odds of getting one of them right? Which, of course, a lot of the time when we have repeated trials, whether it be 1, 2, particularly 3. If you go to 3 trials, we can't do these 2-way tables, can we? So, tree diagram, and it can be with and without replacement. So, in this example here, we're going to have a look at drawing a tree diagram. Now, that a lot of the time we'll ask you in your assessment, please draw a tree diagram, and from that tree diagram we'd ask you several questions. Now, it says 2 multiple choice questions, draw a tree diagram. Well, we'll talk about this. This is our first sample, and our sample space is A, B, C and D, isn't it? Now, you've got to give yourself some room for these because, as it turns out, we know that A, B, C and D, if I pick A, B, C and D, I've then got this, don't I? Because A can be from my first, B, C or D. I can pick one of those. There's a total of, if I pick A, I've got a total of 4 combinations if I pick A first. Then, if I pick B, I can go A, B, C and D. These 2 events are independent though. You can pick A and then you can pick A again. Has no effect on the other. And of course, that's why I said leave room. You would obviously leave yourself more room. And I've got A, B, C and D, yes? So do yourself a favour and give yourself plenty of room when doing your tree diagrams. 1 second. All right, so that was a really good question. Why do we do it like this? Well, because in other words, we can actually see that there is a total of 16 outcomes. Let's do our counting again. Okay, we're back. I feel like we're in play school or something. Okay, we've got 1 outcome, 2 outcomes, 3, 4. If I pick B, 5, 6, 7. What's that? That Dracula, wasn't he? 8, 9, 10, 11, 12, 13, 14. Oh, I counted incorrectly. There was 16. All right. Now, it does not say, however, the probabilities. Shh. We know the probability of each is what? What's the probability?
1 out of 16.
For each individual one. Each question, 1 out of 4. Yes. Now, if I think about this way, I've drawn a very basic tree without the probabilities. All right, I'm going to pause this here whilst. All right, so we've had a little pause there. We've had a bit of a break, and the tree diagram there should have the probabilities on them. I've said and so on because I'm a bit lazy and don't want to do it. But let's have a look then. At these questions. Sam's not studied. The answers were C and B in that order. What is the probability he gets both answers correct. Well, the probability if C and B in that order means that we need to... What's going on there? Okay. What is going on? Seriously. The probability of C and B in that order is, well, the probability of C then B, we can look from our tree diagram. We can get our highlighter out if you like, which I'll do.
It's not writing on the board.
It's not writing. That sucks. Set, go. All right. Probability of C then B is, well, I've got 1/4, and then the probability to get B is also 1/4. So, of course, you can see that on your tree diagram. So, let's label that. So what we then do is we go ahead and probability of C and B, we then multiply those probabilities together. So that is 1/4 times 1/4, which is equal to 1/16. Now, that's okay if you've only got one outcome. One outcome, it only happens once out of 16. What about why a tree diagram is beneficial is when we get things such as he gets at least one correct. You can see there that we've got the sample space. So the probability of one correct, we can go ahead and shade that on our tree diagram if you like. So I'll get my little highlighter out. It was C and then B. So let's do the ones that are correct in yellow. Well, of course, he needs to get... If he gets C correct, then there's only one option there, which means the other one's correct, and that is B. So that's one. What about if he gets each one of them wrong? He could go A and then B, couldn't he? And we have one correct. He could go B and then B, and he'd have the second one correct. He could go C and then B, which means he's got both correct. And he could go D and then B, meaning he has another one correct. Now, what we have to then do is we have to multiply those and add them together. Yeah, so if you get C, so there's 4 of those, isn't there? Yeah, that's right. Very good.
Is there any other way to do it rather than just counting the possibilities?
No, that's pretty much it. All right, so the probability of at least one correct, if you like, we could write that out like so. That's the probability, that's the same as getting the probability of, he could go A, then B, plus the probability of B, then C. B was the correct answer in the second one, wasn't it? B, then B. Plus, he could get the probability of C, then anything. I'm trying to put some words to this. Plus, he could get the probability of D, which means it's incorrect, then B, isn't it? Okay, so let's add those all. The probability of A then B is what? 1/4 times 1/4. Probability of B then B is 1/4 times 1/4. The probability of C then anything. Well, if we don't care which one, so we pick C, the probability of C is 1/4, and then we've got 4 out of 4, or 1, if you like, because he's got one correct anyway. So that is times 4. How many outcomes does he... Well, it's actually 1/4 times 4 over 4, which is 1. Yeah? And then the probability of D then B is a quarter times a quarter. Okay. Why have I lost my pen again? Now what you need to do is add all of those up. Now as it turns out, each one of those is 1 out of 16 if you like. He's got 4 options plus 1 plus 1 plus 1. Shouldn't that be 7 out of 16? Well, let's go ahead and work it out. So that is 1 out of 16 plus 1 out of 16 plus... Yeah, no. This one is plus a quarter. And this one's plus 1 over 16. Because when he picks... It's quarter times 4 over 4. Set, go. So as you can see, if you like, because each one has the same probability, we could have counted the number of outcomes, the amount of times we highlighted on that tree. That was 1 plus 1 plus 4 plus 1, which was 7 out of 16. Or we could, of course, multiply each, and as it turns out, as you can see there, it's a total of 7 out of 16. That's a probability of getting one correct, at least one correct. So if you guess both, there's a 7 out of 16, which is, not too bad. Not too bad. Yeah, you're still looking at under 50%, aren't you? Well and truly. But then if you repeated that dose and then you had 3 and 4 and 5, suddenly you're not getting so many. However, what is the probability he doesn't get either correct? How many of those were options? He doesn't get either correct. Well, if we go... considering the first answer was C, wasn't it? The first answer was C, meaning all of these. But not including... B was the second one. Not including that one. So, how many of those could he get? He doesn't get either correct. So there's 1, 2, 3, yeah? What about the second one? If he chooses B, there's also 3. If he chooses C, well, there's no way you can choose C first. So there's only a total of 3 and 3. And then in D, he's got another 3. So therefore, by using the tree diagram, you can say that the probability that none are correct is equal to what? 9 out of 16. You could multiply the probabilities together, but using the tree. All right, now this time let's try another one, and this is why we do tree. This is the main benefit of tree diagrams. I'm going to give it a pause, and I'm going to get you guys to try this. What I'm going to get you to do is try to come up with your own tree diagram. However, what I'd like you to start with is first of all, that the weather is fine and the weather is not fine. We could do that as well. That was just me. That was my one. You got the wrong one. All right, that's good. So we could do that. As long as you guys know what it is, that's fine. Then we've got win and we've got loss. And we've got, if it's not fine, we've got a win or a loss. Now, What I'd like you to do is fill out the probability tree, please, and fill it out with the probabilities. If it's fine, it says here the chance of victory is 4/5. And the probability that it's going to be fine for a day is 3/4. So quickly fill that out. Okay, now, the underlying question for this is, what is the probability of a win? And by drawing a tree diagram, we can see that if the weather's fine, the probability of the weather being fine in the first place is 3/4. The probability of it not being fine, of course, it's either fine or it's not fine. There's no in between. So they must add up to 1. Then, over here, the probability of a win is 4/5. The probability of a loss must therefore be 1/5. So the probability of a win is going to be, first of all, we can say that is the same as the probability of it being fine, then a win. But there's also another one. It can be not fine. Of not fine, then a win. Now, how do we find out the probability of it's fine, then a win? Well, we need to multiply those two together, don't we? 3, oops. No, it's not the probability. Let's just work it out. That's going to be...
Just be able to times the probabilities together?
Correct. 3/4 times 4/5. That's for that outcome there. Then we are adding 1/4 times 1/3. Okay. Hope you're following me so far. Now let's just do our fractions. That's the same as, they're going to cancel out. 3/5 plus 1/12. What would be my LCD over here? What would be my LCD? 60. So I've got to multiply 3 by 12 to get 60. So that's the same as 36 out of 60 plus 5 out of 60. So therefore, my probability of winning is 41 out of 60.
Why couldn't you just multiply the two ones together, like a fine day and a win? So 3/4 times 4.
Let's work through this together. This is how you do it. This is from last year's test. So, first of all, we have got marbles and it's without replacement. We can either pick a white... We can either pick a white marble. That's our first one. Or we can pick a blue marble. Now, in my first trial, what is the probability that I'm going to get a white marble? 7 out of 11. Good. Okay, now that's good. What's left? Well, it has to be 4 out of 11. Now, we repeat the dose because if I get a white marble, I can get a white again. But how many whites are remaining? 6 whites out of? It's without...
You can't get double again.
No, what am I saying? 10.
6 out of 10, isn't it? Now, if I've picked 6 out of 10, that means that it needs to be 4 out of 10, a blue.
Can you leave it in like not simplified, make it easier?
Yeah, okay, I will. But I can't simplify 7 over 11.
Yeah, but no, you can simplify 6 over 10 in a math text right left of that.
That's fine. I would suggest that. Shh. If I pick a blue, the chance of being a white, there are 7 out of 10. 7 out of 10 are white, 3 out of 10 are blue. Sorry, yeah, 3 out of 10 are blue. Okay, we have now drawn a tree diagram. Now it says find the probability of selecting a blue followed by a white marble.
But what does it mean drawing it without replacement?
if I take a blue out and there's 4, there's now 3.
Oh, okay.
If I've taken it out of 11, there's now 10.
Okay.
So the probability of blue, then white. Let's just finish this off. Probability of blue, then white is
4/11
times 7 over 10. Beautiful. Two marbles of the same colour, you would have to then go that plus that, and so on. All right? I would like you to try and have a go at questions from E and F.